It's time for some more chemistry because it is all that matters, and today we're going to be doing some calculating of density. So density is a ratio of the mass of the object in the unit of volume. So if you had a very tiny volume with a large mass, that would be something that's really dense. And if you had a huge volume but very low mass, that would be a very low density. So it is a relationship between mass and volume. So that is the equation. Density equals mass over volume. And this equation can be rearranged to density times volume equals the mass, and likewise volume equals mass divided by the density. Now for our purposes here in chemistry, we are going to typically use grams per milliliter or grams per centimeter cubed depending on how the volume was measured. So once again, grams over milliliters or grams over centimeters cubed based on what values we are using. Now, one way we can remember this equation is if we're working with density, we really want to love our density. And so therefore it's mass over volume, and we are in love with density. So just to remind you from your geometry, a cube is measured by volume as s cubed, side times side times side. And if that cube is a prism, we then have a different measure for each side, so it's length times width times height. And if we have a cylinder, we're going to find the area of the base, which is pi r squared, and we're going to multiply that by the height of the cylinder, so it's pi r squared h. And if we have a sphere, it's 4/3 pi r cubed. So the radius cubed times 4/3 pi. Sometimes, however, we get objects that don't have regular measurements that are easy to measure with a ruler or other device. So therefore, we can also calculate volume using a method called displacement. So here we have this irregularly shaped pebble. We have a graduated cylinder. In the graduated cylinder, we currently have 60 milliliters of water. When we place the pebble into the water, we notice that the water level rises, and it rises up to 80, which means the volume of this rock is 20 milliliters. So by changing the volume of the liquid, and we use water because water has a value of 1 gram per milliliter or 1 gram per centimeter cubed, we know that the volumes are equal when we place an object in it. The amount of volume that it is changed is the volume of that object. So let's do a very basic density problem here, and here we have find the density of a die that has a mass of 1.2 grams and measures 1.5 centimeters on each side. So we are looking for the density, so of course we're going to use the density formula, D equals m over v. And like any problem solving, we're going to look for what we know already, and we know the mass is 1.2 grams, and we know that the volume is created by taking the sides of the cube, and a die is a cube, so we're going to do s cubed, 1.5 centimeters cubed, and that gives us a volume of 3.375 centimeters cubed. So we are simply going to place that into the formula for density, 1.2 grams over 3.375 centimeters cubed, and that calculation comes out to be 0.35 grams per centimeter cubed. Now, why did I round to 2 decimals? Well, remember from our significant digit rules, this is division. And so 1.2 has 2 significant digits, 3.375 has 4 significant digits, and when you do multiplication and division, the answer must mirror or be the same as the new number from the question with the fewest significant digits. So in this case, 2 significant digits is our correct answer. So there's a second video that goes with this Sophia tutorial that has density by displacement. So go ahead and watch that video and then do the questions that are associated with this tutorial.